Okay, now on this second example, this one has already been factored for us. So when it's factored, it makes it easier to find the holes in vertical asymptotes. It is actually a little bit harder to find the horizontal asymptotes. But when I'm looking for my holes in vertical asymptotes, remember a hole is created by a factor that cancels out. In this case, the 2x plus 3 and the x plus 3 don't match, so they don't cancel. So there are no holes. So I'm just going to put none for holes. And then vertical asymptote is a factor that does not cancel out. So the x minus 1 would give me a vertical asymptote at x equals 1. And then the 2x plus 3, that one you might not be able to get just looking at it. But if I set it equal to 0 and solve for x, I'll subtract 3 from both sides. So 2x is negative 3, then divide by 2, and x is negative 3 halves. So I have a vertical asymptote at 1 and negative 3 halves. And this kind of explains the note I put in your written notes that there's a lot of variation in what these can look like. The first example we did had a hole, a vertical asymptote, and a horizontal asymptote. This one has no hole, but it has 2 vertical asymptotes. So you get a lot of variation. Now, to be able to find the horizontal asymptote algebraically, I need to put this in standard form. So the numerator is already in standard form, x plus 3. The denominator, I would need to multiply that out. So that's 2x times x is 2x squared. I would have a 2x times 1 is a minus 2x. I'm going to write that over here. And then a 3 times x is a plus 3x. And then I would be able to add those like terms together. So minus 2x plus 3x is plus x. And then 3 times minus 1 is negative 3. So now that it is in standard form, I'm comparing the highest ones again. So to get this horizontal asymptote, I'm comparing the highest powers. In this case, my highest degree is x squared. So I have a 2x squared on bottom. And once again, I have no x squares on top, so that is a 0x squared. And the truth is, anytime you have more x squares on the bottom, a higher degree of x on the bottom than you do on the top, you're going to get 0 over something, which is going to give you a horizontal asymptote of y equals 0. If you were to graph this in Desmos, let's go ahead and do that, and then make sure those asymptotes are correct. So you notice I just graphed it in the original form in Desmos. Desmos doesn't care if it's factored or simplified, so I just give it whatever form that they started me off with. And the vertical asymptote of 1, you can see that this branch comes close to 1, and does this branch. Any vertical asymptote, you should have a branch coming close to it on the right side and a branch on the left side. The vertical asymptote at negative 3 halves, you have a branch coming on the left, a branch coming close on the right. You do have this weird parabola-shaped branch in the middle. The horizontal asymptote of y equals 0. Notice that this branch on the right side does get right close to it, so it is a legitimate horizontal asymptote. It might bother you a little bit that this side crosses, but just be aware in these weird graphs that have multiple vertical asymptotes, it's possible that the asymptote applies to multiple vertical asymptotes. It's possible that the horizontal asymptote only applies to one portion of the graph. In this case, it only applies to the piece on the right, not the piece on the left. You don't really have to worry about that. Just don't be surprised when you're checking it with Desmos if you find out that part of the graph does cross that horizontal asymptote. It's still a legitimate answer because this piece of the graph does not. We'll try to do one more example.